let's say that these two persons in here, they want to communicate and trade information with each other. So the easiest way for them is to talk. So let's say, for example, this man in here, he says hello. If we convert the sound that he has created into electrical signal, we would see something like this. So a signal is a function which carries information. This signal would travel through the air and gets to the other side. In this case, this woman, by using her ear, would receive this data, gives that to her brain, and she could make sense of this data in here, and her brain could make the related and corresponding response and send back the information. So in this case, the ear is actually acting as an interface for communicating the information in a network of people. So we could name it as a network interface card. So both of these persons, they both have two network interface cards. One of them for sending information, for sending information, for example, the mouth or tongue or anything that you want to name it, and the other one is the ear. Their brain would act as the central processing unit or the CPU, and the medium in here is air. So this whole process is a wireless process. Now let's say that they are far more distant with each other, that they can just trade information by making voices and talking. So instead, both of them would use a light bulb. But before that, they would just want to create a set of rules and then talk using this light bulb. For example, before they start the communication, they would say that the set of rules are as following: that if I turn on my light bulb one time, then it suggests that it is the A word. So if you see the light bulb turning on one time in a second, then you could decode it as A. If it is on for 2 seconds, or if we have 2 ons, you could decode it as B, and so on. But in this case, we would have A through Z. So for example, for Z we may have 26 on for 20 seconds, 26 seconds, and so on. We have some difficulties. So instead of that, let's say that we would use 2 light bulbs. So we would encode all the characters using 2 light bulbs, or we could say again by making a timer of 1 second. So if I have 2 light bulbs off, or in a better way, if my bulb is off for 2 seconds, the first 1 second is actually we could just say that the first bulb is a representation of the light bulb in here for 1 second, and the second one is for the second number 2. So if they are both off, then it is A. If the first one is off, the second one is on. Or in the first second it is off, and for the second second it is on, we could say it's B. If the first one is on, second is off, it is C, and so on. But in this case, we could only encode for different characters. So instead of that, because we know using n digits we could only encode 2 to the power of n characters, so we would say that I'm going to use 8 digits. So in this case, we could encode 2 to the power of 8, which is equal to 256 different characters. So in this case, if all my 8 light bulbs are off, then it would be A. If the last one, or if we are computing from left to right, if our right hand side light bulb is on and all the others are off, we have B, and then we have C, and so on. Because light bulbs only have 2 states, so it is kind of binary, 2 states. So we could call every one of these a binary digit, or for summary we could call it bit. So binary digit or bit. So they make in their set of rules that they are making, that they call it a protocol. They say that, let's say instead, when you are going to decode the information, instead of saying off and on, you could say 0 and 1. So we make a convention that if the light bulb is off, we call it a 0. If it is on, we call it a 1. We call every one of these 0 or 1 a bit, and we call every 8-bit 1 byte. The most right-hand side bit would be called the least significant bit, and the left-hand side bit would be called the most significant bit. So if we have 1 byte of information which the least significant bit is 1, then it would be decoded as B, as you see in here. So we could just say that these information are like this. They both represent one information. So as you see, just using two states and zeros and ones, they could talk to each other and tell anything that they want to say. So it seems like for communication, the only thing that we need to do is just send zeros and ones. So instead of sending information through the air, we could connect everything using the wire. That's when the telephone were created. So in this case, every home was connected to each other using the electrical posts and wires. So all the required information to talking to each other was sent and received through these wires. And when the computers were invented, and then we wanted to create the internet to send and receive all the data through this wire, we use this platform in here. So as you see, for example, in a section, all of these things, all of these houses were connected to each other. Then again, these sections again were connected to each other using wires. And if they were a lot of different cities and countries, and you see sea and oceans between them, again they were all connected to each other using wires, but the kind of wires were just different. For example, for sections they would use a copper wire, while for countries in the sea and oceans they will use fiber optic to transfer the data across the sea and oceans. So for example, let's say that someone in this section wants to send some data to a person in another country outside the sea. So in this case, for example, he would send the data to the router. The modem would modulate the data. We would talk about every one of these devices and concepts in later videos, but the data would go to the ISP or internet service provider, which is here. The router in the ISP would forward it to different sections because they are all connected through the wire. Data would come in here, it would travel through the fiber optic which is in the sea to go to the other side, and then the packet would be directed, guided and forwarded through different wires until it gets to the destination. Now how the packet knows, or we could say how the devices that are in the process between the traveling of the packet know how to forward the packets, are some important concepts that we will be talking about in the next lectures. Now if we look at in this case, in the first case, for example, in here, the source and the destination which were creating and receiving the information, they were both human. But then in the next cases, for example, in this case, the source and destination were computers. So somehow we needed to tell computers what to say. And we know that only the computers could only understand zeros and ones. So at first we had to just, for example, write zeros and ones in different ways, for example, on punch cards, and give it to computer to tell them, for example, how to direct and forward the data to the destinations and so on, or how to change or make some calculations and computations on those data, and then forward them to the next nodes. Because for us, working with numbers for zeros and ones was very hard, so there was just a small group of people that were capable of writing instructions for computers. So after some time, the programming languages were created, an easier way for talking to computers. So programming languages are just some way to talk to computers. So for example, let's say that someone in a section in here wants to send some data which he wants to, for example, be directed in some special way, and some calculation be done on the data and then be forwarded or something else. So first he would look at the process in here, he would know everything about the networking, and then he should tell the computer how to forward it or other devices in between. So in this case he would use the programming languages. He would talk to computer using the programming languages. The compiler would translate, the compiler is software which would translate the instructions, the commands in the programming languages to the machine instructions so that the computer could understand. And we could say that it is a bridge between us as human and the computer. Now a hacker is a computer scientist who would want to look at the vulnerability and exploit them in the benefit of his own. For example, let's say that he is looking at the network in here and he wants to receive the data while he can't access them. So for example, in here, in one of these wires in here that he wants to receive the information, he would cut the wire to maybe, for example, just disable the communication, like the denial of service attack that you would be familiar with. They both have the same concept, denial of service. Or he may just add another branch of wire in here so that he also could sniff the data, and he put himself in the middle of the communication. Or he may even look for the programs, find the source code of some programs which are somehow deciding to tell computer what to do, and he changes that code or find the vulnerability and exploit that so that the program of those people would not do the thing that it was supposed to do, but would do the thing that the hacker wants to do. So in the earlier years, a hacker was someone who knew every detail and concept of networking, for example, of programming languages, how to talk to computer, and if he wants to do some security penetration testing on some networking thing, he would know all the process in the networking, every detail, how the packet is forwarded in every device. And then using the programming language which he was also familiar with, he would tell the computer what to do, but in his own benefit.